Hello there, Mr. Sutton here, bringing you the AB Calculus 3-8 homework solutions on implicit differentiation. For number 12, they want the derivative of sine of xy equals x. This one's actually a bit more of a pain than it looks like it's going to be. So we've got sine of xy. This is a chain rule with a product rule inside. And of course, there's y's inside for that product rule. So let's do the outer derivative. That would be cosine of xy times the tail, which is a product rule. I'm going to go to my box for the product rule. We've got x and y. Derivatives are 1 and dy over dx. So using my ribbon, I've got y plus x dy dx. And then we have equals the derivative of x, which is just 1. All right, so our whole goal here is to get dy over dx by itself at this point. Half a dozen to one, 6 of the other, which way you want to do this. I think ultimately it'll be easiest to distribute this cosine and then work from there. So I'm going to go ahead and do that. We've got cosine of xy times y and cosine times this term over here. Now I'm going to subtract the y cosine of xy from both sides. So 1 minus that. Now I just have to divide by x and cosine of xy. And let's see if I can match that with any of the answer choices. It's looking like choice D has what we're looking for, so we're done. For number 8, we're given this equation and we want the derivative. Now in here, since y is difficult to isolate, we're going to use implicit differentiation. Going from left to right, we've got 2x, and then I'll use the product rule for this xy product. So we've got x, y, derivatives are 1 and dy over dx. So using my ribbon, that's going to be y plus x times dy over dx. Next up, we got y cubed, so that'll become 3y squared dy over dx equals derivative of 0 is still 0. All right, let's get all the non-dy over dx stuff to the right side. So I'm subtracting the 2x and the y. And now I can factor a dy over dx out of the left side and divide by x plus 3y squared. So that would be almost my final answer. If we look at the answer choices, it doesn't really exactly match any of them. Now you can definitely eliminate B, C, D. Those aren't even close. E has too many things in the denominator. If you were to factor a -1 out of the numerator, you would end up with choice A here. So sometimes you have to finagle a little bit to make it match, but that's the one. For this problem, we're given this equation here, and we're asked to find the derivative at the point -1, 2. So let's start by taking the derivative. Since I can't easily isolate y, we're going to use implicit differentiation on this. So going from left to right, first let's differentiate x squared y. For this, we will need the product rule. So let me set up my box and ribbon here. So I've got an x squared and a y. Derivative of x squared is 2x. Derivative of y is dy over dx. So using the ribbon to multiply all that out, we've got 2xy plus x squared dy over dx. Moving on to the next term now, we have minus 3x, that becomes -3. And over here now we have equals, this is going to be 3y squared dy over dx. We have to use the chain rule there. And then that 3 gets differentiated away to 0. All right, let's isolate our dy dx terms. So the x squared dy over dx is staying on the left side. Along with this 3y squared dy over dx, we actually have to subtract that to get that over there. But now this 2xy, we're going to subtract that over to the right side, along with the 3, which we're going to add over here. Now let's factor out a dy over dx. So that leaves us with x squared minus 3y squared in a parentheses. And we can now divide by x squared minus 3y squared. So that'll be -2xy plus 3 over this stuff. And we're not quite done yet, because after all that, we still have to plug in the point -1, 2. So let's go ahead and do that. Evaluating this derivative at -1, 2, we've got -2 times the x value -1 times a y value of 2, and we also have a plus 3 going on in the numerator. Denominator, we have that x value of -1 that's being squared now, minus 3 times, this will be 2 squared for y. So in the numerator, this is going to be, let's see here, 4 plus 3 is going to be 7. Denominator, we have 1 minus, let's see, this looks like this is going to be 12, so that's negative 11 down there, and that's going to give us an answer choice of choice A. On this problem, we're given this equation, and we want to know the derivative in terms of y. Okay, so let's go ahead and take that derivative. We're going to have to use implicit differentiation, or at least that would help on this one, because y is kind of hard to isolate here. So let's see, we'll do 3x, that becomes a 3. Tan of y, that's going to be secant squared of y, but we're also going to have to multiply by dy over dx because we took the derivative of something with a y, and it's its own inner function, so the chain rule there. Derivative of 4 is 0. Now let's isolate dy over dx, so let's subtract 3 to the other side, and divide by secant squared of y, and that ends up being dy over dx. So does that match any of our answer choices? It does not. However, secant squared of y, that's really 1 over cosine. If that's already in the denominator, we can move it up to the numerator and make this 3 cosine squared of y. That matches an answer choice, choice B. On this problem, we want to know the slope of the secant line, aka the derivative, of this curve at the point 2, 0. Since y is kind of hard to isolate here, let's just use implicit differentiation. Going from left to right, derivative of y, that's going to be dy over dx. And then derivative of 2 is 0. X squared over 2, if we use the power rule, multiplying by 2 cancels out that 2. So you just have x to the first power there. And then negative 2 sine of y, that's going to become negative 2 cosine of y times dy over dx because of the chain rule. Y is an inner function here. All right, let's isolate our dy over dx's. Real quick to do that, we can just add this cosine term over to the left side. And now I've got to factor out a dy over dx. So that'll leave me with 1 plus 2 cosine of y inside. Now dividing by 1 plus 2 cosine of y, we have x over that stuff. And at this point, we're going to have to go ahead and plug in the point 2, 0. So evaluating derivative at 2, 0. In the numerator, we have the x value 2. Denominator, we have 1 plus 2 times the cosine of the y value 0. Cosine of 0, that's going to be 1. So this is really 1 plus 2, which is 3. So 2/3 when the dust settles for choice D. For this problem, I want the derivative at x equals 1 for this function here. Let's start by taking the general derivative. And for that, we're going to need implicit differentiation. This one's awfully tough to isolate y and otherwise. So going left to right, we've got 6x for that first derivative there. And then 2xy, we're going to need the product rule on that one. So setting up my box and ribbon, I've got 2x and y as my two factors. Derivative of 2x is 2. Derivative of y is dy over dx. Using the ribbon to multiply that out, we've got 2y plus 2x dy over dx. Moving on to the next term now, which is y squared. Derivative of that, that'll be 2y times a tail of dy over dx. And all that's going to equal 0 if you take the derivative of 2. Let's now isolate the stuff with dy over dx's. So the 2x dy over dx can stay on the left side. So can the 2y dy over dx. Moving over to the other side, though, we have to subtract 6x and also 2y. Now that I have only dy over dx terms on the left, I can factor out dy over dx, leaving me with 2x plus 2y in a parentheses. Dividing everything by that, I've got negative 6x minus 2y over 2x plus 2y. And if I really wanted to, I could reduce everything by 2. Not sure there's really a value to doing that, though, because we're just going to plug in the point 1 comma... Hey, wait, what's the y value? We need a y value to plug in here, too, because there's an input spot for y. So to actually find the y value, because they only gave you the x value, you have to plug x into the original equation and get a y value out of that, and hopefully only one y value. So plugging in x, we've got 3 times 1 squared plus 2 times 1 times y plus y squared equals 2. So that's going to be, let's see here, 3 plus 2y plus y squared equals 2. And this is a quadratic, so let me just get everything on one side here. Let's subtract the 2 to get it over on the left. So I've got y squared plus 2y plus 1 equals 0. This is factorable. Two things that multiply to 1 and add up to 2, that's just 1 and 1. So y plus 1 quantity squared equals 0, which means that we have a y value of -1. That zeroes that out. All right, so going back to this, we're going to plug in the point 1 comma -1 into this derivative. So let's go ahead and do that. That's going to be -6 times the x value 1 minus 2 times the y value -1. In the denominator, we have 2 times 1 plus 2 times -1 for the y value down there. So this is going to be -6 plus 2, so that's -4 in the numerator. And in the denominator, we have 2 minus 2, which is 0. Well, that's not existing, undefined. So that means that the value of our derivative is not defined. Choice E. For this problem, the slope of the line tangent to this curve at 2 comma -1 is what? So basically, we want dy over dx for this thing at the point 2 comma -1. All right, well, let's go ahead and take our derivative. We're going to need implicit differentiation on this one because y is pretty tough to isolate. So going left to right here, derivative of y squared, that's going to be 2y times a tail of dy over dx. We've got to use the chain rule whenever we differentiate something with a y because it's its own inner function, an implicit function, if you will. Moving on to the next thing, that's this xy plus 1 cubed term. So we're going to have to use a big chain rule here. On the outside, we've got the derivative of something to the third power. So that would be 3 times xy plus 1 to the second power. But now we have to multiply by the derivative of xy plus 1. I'm not really worried about the plus 1 because that's just going to be 0 for a derivative. xy, however, is going to require the product rule. So let me set up my box and ribbon with factors of x and y and their derivatives, which are 1. And this is going to be 1 dy over dx. Using the ribbon to multiply that out, I've got plus y. Or actually, we're multiplying now because all this stuff is being multiplied. It's its own factor because it's a tail here. So we've got y and then plus x dy over dx. All of that in the parentheses now. And then all that's going to equal 0 because 0 is the derivative of 0. All right. Isolating dy over dx is a little bit tricky on this one. There's really no quick and clever way to do this. You either have to, I guess, well, I don't even know what you do. Let's just distribute this out. It's going to be a pain pretty much any way we do this. Let's just grit our teeth and distribute this out. So we're going to have 3y xy plus 1 quantity squared, and we've also got this 2y dy over dx in the beginning. Plus, this is going to be 3x and then xy plus 1 quantity squared dy over dx. All that equaling 0. Let me just isolate this stuff with dy over dx's. Really only one thing I have to do there, which is subtract this 3y xy plus 1 squared. Now everything on the left has a dy over dx, so I can factor out the dy over dx, leaving me with 2y plus 3x parentheses xy plus 1 squared. And I'm going to divide the whole thing on the right side by all this stuff in the parentheses on the left side. So all this coming down here. At this point now, because we haven't done enough work on this one, we also have to plug in the point 2 comma -1. So let's plug that in. Plugging in the x value, let's see, 2 and the y value -1. So we've got -3 times the y value -1. And then we have x value of 2. Y value of -1, all of that plus 1, and that's in a squared parentheses there. Downstairs we have 2 times the y value -1 plus 3 times that x value of 2, and then we have 2 times -1 plus 1 squared, so pretty much the same thing as we had in the numerator. So let's see here, multiplying all this out. Let's tackle the squared parentheses first, because we've got to simplify our answer to get an answer choice. So this is -2 plus 1. Which is -1. Squaring that gives me +1. So that whole squared parentheses in the numerator and the denominator is just 1, so we don't really have to worry too much about it. So what's left in the numerator? -3 times -1, well, that's just +3. Okay, moving down to the denominator. We have a -2, and we have, this is going to be a 6 outside here. Remember, this whole squared parentheses was 1. So negative 2 plus 6 comes out to 4. 3/4 is an answer. That's choice D.